So now let's talk about binomial distributions. So as the name shows, this is a certain type of distributions. So later we will tell you that there are some kind of random events, some kind of random situations that the outcomes can be described as Bernoulli distributions and or binomial distributions. Okay, so now let's say we have Bernoulli trials and we have unindependent Bernoulli trials. So we toss coins once, twice, third time, fourth time, blah blah blah. We toss coins several times. So that's unindependent Bernoulli trials. Or you have customers walking in front of you. One customer, two customer, third customer. Some customers stop and talk to you. Some customers just go away. And suppose each of them stop by and talk to you with some probability P, and they are all independent from each other. So whether this customer stops does not affect the other customer stopping or not. Suppose that's the case. Then that's also a sequence of unindependent Bernoulli trials. In that case, we can say the outcomes are xi, where x1, x2, x3, x4, they are all Bernoulli random variables. Okay, so in that case, let's consider the sum of these Bernoulli random variables. Let's say the sum is y or the sum is x whatever. So in this case, we are counting the number of ones that we observe in the n trials, like the number of heads we observe after tossing a coin 10 times, or the number of men sampled in 1,000 randomly selected people. So these are all examples of a sequence of Bernoulli trials. So if we are tossing a coin 10 times, then how many heads we may observe? 0, that's possible. 1, that's possible. 2, that's possible. Up to what? Up to 10. All these are possible outcomes. And if we are able to characterize, to derive the probabilities for each outcome, then we are describing the probability distribution of that number of heads. That number of heads is random, and we try to characterize the distribution. So here is the same thing. We randomly select 1,000 people, and we ask how many men we may observe in that particular sample. So here we're talking about men. Another situation is that we randomly select 1,000 persons and ask them how many of you are having a smartphone. How many of you are having experiences of shopping online? How many of you has a car? Something like that. So in that case, what we are really considering is a certain proportion, right? As long as you are doing any kinds of survey regarding any kinds of proportions, whether your customer says you are good or not, whether a voter says this candidate is good or not, then that's a sequence of Bernoulli trials. So now let's try to see how may we derive all those probabilities. So what is the probability for us to see x once in n trials? We toss a coin n times. We want to ask, what's the probability for us to see x heads? Okay, so let's start from an easier question of a special case. Let's say n is 5 and x is 2. We want to see the probability that we see 2 ones in 5 trials. Suppose that's the case, then let's ask ourselves, if we do some trials 5 times, what are all the possible ways to see 2 ones? Actually, they are all listed here. For example, you may see 1, 1, 0, 0, 0. Okay, that's case 1. Or in the other way, you can see 1, 0, 1, 0, 0. So that means your first trial, you are successed. And then your second one, you failed. The third one, you succeed. The fourth one, you fail. The last one, you fail. Or say you are tossing coins. The first one, you get head, tail, head, tail, tail. So you have 10 different ways of seeing in total 2 ones Okay, like this. 0, 1, 1, 0, 0, that's possible. 0, 0, 0, 1, 1, that's possible. So after you count all the possibilities, or technically all the possible combinations, then that's the number of possible ways to see two ones. Okay? So now what we want to do is that we should do something by calculating the probability of each one. Okay? All these are events. We may see this, we may see that. All these are events. Technically, we say they are mutually exclusive because when one event occurs, the other event will not occur, right? So all these 10 events, they are not including any one of them. So what we want is the union of these 10 events, okay? All of them may happen, and we count each of them. So we use a so-called special law of addition. So that term looks very special, but anyway, it's not. It simply tells us that if we are able to calculate the probability of each event here, then basically the probability for any of these events is just the sum of all these probabilities. Okay? So let's try to find the probability of each event. There are 10 events here. Let's consider event 1. Event 1 says that I'm calculating the probability for the first trial to get 1, the second trial to get 1, and so on and so on and so on. Technically, we say this is a joint event, which means you need 5 things to happen in the way you like. You need them to happen at the same time, okay, in one single sequence of trials. So that means we need each of them to happen, and they need to happen all together. So if the first thing happens with probability P, and the second thing happens with probability P, then that means for the both of things to happen, the probability is P squared. Okay? You get one head, you get another head. The probability for you to get 2 heads in a row is 1/4, right? Why is that? Because it's 1/2 times 1/2. In general, if the probability for you to get a head is P, another trial you also get a head, then the probability is P squared. So you need to get 2 success. So you have P times P, and you need to get 3 fails. So you have 1 minus P 3 times. So that's how you get P squared times 1 minus P to the power of 3. Okay, so probability for event 1 is this guy. How about event 2? It turns out that it's also the same. The order is different. So you first need a P, and then you need 1 minus P, and then a P again, and then 1 minus P, and then 1 minus P. So in fact, any of these 10 events, the probability for that particular order of outcomes to occur is P squared times 1 minus P to the power of 3. So that means if we are talking about all of these, then what we have is that we have 10 different events. For each of the events to occur, the probability is P squared times 1 minus P cubed. So if that's the case, then the sum of them is just 10 times of that. That's the probability for that particular event to occur. That's the probability for us to see 2 1s and 3 0s. Okay, so lastly, that's coming back to the general case. We need x 1s in n trials. Okay? So that means we want to see x 1s and n minus x 0s. So now we know that the probability for the results to show us to come up with us is the following. We need x 1s. So the probability for that to happen is P to the power of x. Okay? And then we also need several zeros. We need n minus x zeros. For each of them, the probability is 1 minus P. So here we have 1 minus P to the power of n minus x. And then finally, how many numbers of trials do we have when we are doing X trials out of N trials? Then that's exactly the combination thing that we know in the past. The combination thing that we learned about, if we want to choose 2 persons out of 5 persons, how many different ways do I have? 10. If I want to choose 3 persons out of 6 persons, how many persons do I have? We have 20. Okay, so that's some numbers we are able to calculate. So now if you are unfamiliar with the notations here about that choosing thing, about that factorial thing, you may feel afraid, but don't worry, Excel can take over all these things. So as long as you know what we are calculating, you don't need to worry about the formula. The reason that I'm explaining all the things is just to give you some foundation. But eventually, when you do the calculations, Excel does everything. Okay, so now we are ready to formally introduce binomial distribution. The variable, the sum of independent Bernoulli trials, follows binomial distribution. So a random variable x follows the binomial distribution with parameter n and p. N is the number of trials. P is the probability for each trial to be a success. You do n trials, and then the number of success you observe follows a binomial distribution with parameters n and p if the probability function is the following. So we first do n choose x to get the number of possible combinations of getting x success and n minus x fails. And then for each possible combination, we have the probability p to the power of x times 1 minus p to the power of n minus x. And then that's the probability function for a binomial distribution.